Okay, here's an example where we're actually going to fill the table in on our own. So on this one we have the limit as x approaches 0, with this being our function. So we're going to find out what this limit is. Now remember, this is always an x value, and what it's equal to is called your limit, but it's always, your limit's always going to be a y value. So this time this table's not completely filled in for you. Again, your top row is your x values. Of course, f of x is the same thing as y, so we'll have our y values here. So I've got the 0 in the middle, so we're going to have the values, that have, this would be considered approaching it from the right side. This would be approaching it from the left side. And actually, when you go to do your homework, the numbers that they want you to use for x will actually already be in your table. So you're not going to have to fill in your x values. You'll just have to fill in your y values. Now, I've made a little note over there to the side. I said set your table to ask mode. That's just going to be the easy way that you can get this table filled in. And I'll talk about the graph that you see here in just a minute. But let's first of all get things set up to use with our calculator. You do need to, first of all, enter your function into your y equals. Of course, this being your function here, so I'd have x divided by, now you would need to put your denominator in a set of parentheses, so open parentheses, square root of x plus 1. Of course, close the parentheses, that's around the x plus 1, minus 1, and then you got another set to close, okay? Now, I mean, if you hit graph right now, then what you'll see is this right here, but we're not concerned with looking at the graph just yet. All right, so what I mean by set your calculator to ask mode, if you will go to second window, and these numbers here in your calculator may be different than mine, which is fine, but here is independent, which your independent variable on these problems is your x's. So you're going to put it in ask. So you need to come over here and highlight ask. What that is, when you look at your table, how your x values are always filled in for you because your calculator set in auto for it to automatically fill. You're going to only fill it with the numbers that you want, so we're going to put it in ask mode, okay? So at this point, if you go to second graph, go to your table. Now you may have some numbers in there where you've possibly worked with this before, and you can just delete out if there's anything that's in there. But you just start typing in these x values that you have. Let me scoop this up a little bit. So just start out with negative 0.01. Okay, so you're going to have 1.995. And you start filling in your table, 1.995. And then we've got negative 0.001. So 1.9995. Negative 0.0001. So that's going to give me 1.9999. So if you start looking at your numbers that you have here, it appears that these numbers are getting closer and closer to 2. Okay, so let's see what happens on this other side. So let's just keep going across here. 0.001. Let me shift sides here so I can write it. So that's going to be 2.0005, 0.001, okay, so see, you actually didn't see a difference here. If your table showed you more decimal places, then you would possibly see a difference here. But even as you go from here to here, this number has gotten smaller. Okay, so again, you can tell, you've gone from here to here, which has gotten closer and closer to 2, which appears to be what these numbers. So it appears that this limit here would be 2, which means back up here where I drew the blank just a few minutes ago, that should be your limit. Okay. So that's how you can use a table in order to figure out what your limit is. Now, look at your graph. Okay, so this is your x value. This is a y value. Okay, so let's see if that matches up with what the graph is. So this is the graph of this function. Alright, so as x approaches 0, so of course right here is 0, your x value of 0. So if you look at it from the right hand side, like if you were just to start tracing over this right hand side, as this gets closer and closer to x equals 0, you're also getting closer again to this open circle that's right here. But where is that open circle? It's at positive 2, but that would be your y value. Right there you have y equal 2, which is what we figured out our limit to be. Same thing is true as if you start looking at this graph from the left hand side. See, if you look from, and that's what you've got to do. You do have to look at, if you're looking at your graph, you've got to look at it from both sides and make sure that it is approaching the same number from the left side as it is the right side. And we'll actually here in a minute start talking about, well, what if it doesn't approach the same thing from both sides? But for right now, these examples are. Now, if you were to look at this one in your calculator, if I were to graph it, let me change my window here. Of course, I could zoom in where it would be a little bit closer, but of course, what you're, this part that you're seeing is this part that's right here. Even if I zoomed in some more, closer to that area, let me just do a zoom box here real quick. You'll notice on your calculator where this had that open circle right there, your calculator's not going to show you an open circle, okay? Of course, the reason why you have an open circle on the graph, of course, think about what the x value is. The x value right here is an x value of 0. If you were to substitute 0 in, of course, you'd have the square root of 0 plus 1. So square root of 1 is 1, and 1 minus 1 is 0. Your function, again, is undefined at 0, but yet that doesn't keep you from having an answer for the limit as x approaches 0. Okay? But just remember, your calculator is not going to show you holes in your graph, so, be careful about that. Alright, here's a little statement, and this is kind of what I've already been saying, or what I just finished saying. It says it's important to realize that the existence or non-existence of the function at x equals c has no bearing on the existence of the limit. Okay, so these two problems that I've just finished talking about that had the hole in the graph, that means the function did not exist at that point, but yet I still had a limit. So whether the function exists or doesn't exist has no bearing on the existence of the limit. So your function may not exist there, but yet the limit will exist. Or sometimes they neither one exist. Okay, so you can have all kinds of different combinations. Just don't assume because one thing doesn't exist, the other one doesn't.